Okay, today we're going to learn about expected value. And so this is usually involved in games of chance, like kind you might see in a casino or something like that, where you can win, where money's involved, typically with expected value, not always. Um, but we're going to talk about some of these types of things. So the first thing is we're going to use these A's for the amount or the outcomes that you would have. An amount can be positive or negative. Sometimes you win money, sometimes you lose money when you play a game of chance. Probabilities will be different sometimes for each event. Sometimes they're the same. And in the end, we're trying to find the mean or the expected value. Another name for that is the mean of the game. And so that's like the outcome. If the mean is or expected value is positive, that's a really good game to play because the odds are in your favor. If the expected value is negative, you're probably going to lose money if you keep playing that game. So kind of keep that in mind as we go through here. So let's talk about this first one. What I like to do is set up a table. So when I'm read a problem, I want to set up kind of a table with, um, in this case, let's just read it. It costs $4 to play the game. Die is rolled. You get $1 times the amount rolled. What is the expected value? So right away, you're rolling a die. It looks like there's going to be probably 6 possible outcomes here. So let me, so let's see. So I'm going to call this A for amount or amount you're going to get at the end and the probability of that amount. And so we'll have different outcomes here. It looks like there's going to be 6 outcomes. So 1, 2, 3, 4, 5, 6. Probabilities for each of those are 1/6, right? You can roll a 1, you can roll a 2. They're all equally likely when you roll a die. I guess you could, if you want to, at the top, you could put, your 1, 2, 3, 4, 5, and 6. Those are your different outcomes that you can have. But really, we want to get the amount for each one here. So if you roll a 6, you win, according to this, $1 times the amount that was rolled. So $6, but you had to pay $4 to play. So it's a profit of $2. So woohoo, you get $2. You roll 5, you get $5, which after the cost of 4 is you get $1. $4, you win $4, but you paid $4 to play. You don't really win. $3, unfortunately, you'll get 3 back, and so you're going to lose $1. $2, you're going to win, but you paid $4, so that's a loss of $2. And then if you win $1, you actually paid a total of $3. So those are all your different outcomes. So the way this formula works is you're basically taking, the amount times the probability here. So you're going to have, in this case, the amount times the probability. So this is going to be E equals 3 or negative 3, I should say, times 1/6 plus, so there's a plus sign, then the next amount times the next probability. So plus negative 2 times 1/6 plus dot, dot, dot. So there can be many, many different amount times probabilities. You're just multiplying these two. Now I'm going to multiply these two. So add negative 1 times 1/6 plus 0 times 1/6. You could just put 0 there. Plus 1 times 1/6. Again, you could just put 1/6 there. Plus 2 times 1/6. And you're going to type that into your calculator. So I typed that in my calculator. I got negative 1/2. This time I'm going to copy and paste that. So mouse up, press enter, and I'm going to hit Control Enter. And that gives me the decimal. I really want the decimal here. So I want negative 0.5 or negative. Think about this in terms of money. So you're losing 50 cents every time you play this game. On average, you're losing 50 cents. You're never actually losing 50 cents. You're either gaining $1, gaining $2, breaking even, losing $1, losing $2. But if you kept playing this game, if you played this game 10 times, you'd probably lose about $5. If you played it 100 times, you'd lose about $50, right? You're losing 50 cents on the dollar. So you're actually losing half your money every time you play this game. Like, it's not, that's not that good, right? We don't want to lose half of our money when we play a game, but it kind of works out like that. So it gives you like the mean or the expected value of playing this game. And this is very useful because, you know, you probably wouldn't want to play this game if you had the option to play it. This is a game that's found at a casino called Roulette. You might have seen it on a movie set or something. A lot of James Bond movies, they play roulette at some point. There's a little ball that spins around. You see that little ball right there? It spins around the edge and then it falls into one of the holes there to one of the numbers. And that's your lucky number that you chose. So there are 36 red and black numbers. You can see that. There are 2 green numbers. And for a total of 38 numbers. If you place a bet on one of the numbers and win, you get 35 times the amount you bet. What is the expected value of a $1 bet? Okay, so let's kind of, draw out our table here. So we have amounts here, or this is how much we actually get. And then we have the probability of winning that. So in this case, I don't think we really have, we could, I guess, do 38 different columns, but I really think of this as just 2 columns. A lot of times that's what this ends up being. I'm going to think of this as winning and losing, because that's really what you're going to do here. You're either going to win or you're going to lose. So sometimes it's just easier to think about it that way. In this case, we don't really have to think about every case specifically. You win or you lose. So if you win, let's say you bet $1, right? It cost $1 to play the game. So if you win, how much do you win if you bet $1 here? So I mean, it's tricky, isn't it? So if you get 35 times the amount you bet. So if you bet $1, you get 35 times dollars back. So I paid $1 to play, and they give me back $35. So I think you're actually winning $34. So you really have to subtract the cost of playing in order to figure out the amount you win. The probability of winning, let's see, there are 38 numbers, so I guess 1 out of 38 times you would probably win. Losing, if you lose, well, you lose $1, right? You bet $1, you lose it. Probability of that happening is every other time, which is 37 over 38. So this is, again, the formula is P equals the amount times the probability plus the amount times the probability times plus ... In this case, there's really only 2 of those. So let's do it for both of them. Okay, so we have these 2 multiplied. This will be, so E, the expected value is 34 times 1/38 plus -1 times 37 over 38. Let's see how good or bad the probability is in playing this game. Okay, so I typed this in my calculator. I got a fraction, which doesn't mean a whole lot to me. So I'm going to go up here and copy and paste this and hit Control Enter, and it gives me a decimal. So negative point, I'm going to round that to negative to make it money, negative 0.08. So negative 0.08. So every time I bet $1, I lose about 8 cents, losing about 8% of my money every time I play this game. And this is very typical of a casino. They don't make their money in huge chunks from you. Oftentimes, you lose, just a little bit every time you play on average. Sometimes you win, for sure. But if you kept playing, if you played 10 times, you would expect to lose 80 cents. That's not bad. If you played 100 times, you spent $100, you would lose about $8. You're going to lose about 8% of your money, or 8 cents on every dollar that you spend, you're going to lose on average. Now, it never actually happens that way. You either win big or you lose your dollar, but on average, or the mean expected value, is 8 cents. So you're losing 8 cents on the dollar, 8% of your money every time you play. This is the rest. The odds are in the casino's favor, right? They're not going to give you, let you come and gamble and have the odds be in your favor. That's not going to work out as a business. And so they make sure the odds are always in their favor. That's actually one of the better bets, if there's such a thing as a casino. The odds are always against you, but sometimes the odds are more against you than just 8%. So it's not the worst bet you can make in a casino, but it's not going to make you rich for sure. Let's try this one. The game consists of drawing a card from the deck. If you happen to draw a jack of spades, you win $60. It costs $1 to play. Are the odds in your favor? So again, I want you to get in the habit of writing out the amount, probability. In this case, I think there really are only two options. Again, I think of this as win or lose. So probability of winning is, well, I guess you win $60, but you paid $1, so $59 is your win. You lose $1 if you lose. The odds of winning, there's 52 cards, so 1 out of 52. The odds of losing would be 51 out of 52. So then you just set up your expected value. Expected value is 59 times 1 over 52 plus, this should be interesting if this one, does it seem like a good game to you? Let's multiply it out and we'll find out here. Okay, so let's, the big reveal, we get, well, 2/13. Again, I'll just press Control Enter, get the decimal. About 15 cents. So what's interesting about this one is you're actually making money on average. Every dollar you spend, you're making 15 cents. So if you spend $1, well, you might make 15 cents. If you spend $100, you'd make $15 on average. I would play this game all day, every day if I could. However, no casino is going to offer this game, right? It's not in their best interest. The odds are in your favor. So this is just kind of a made up math example here. This is not something a casino would ever do for you because you're gaining money as a customer every time you play on average. And so they're going to lose money if they start offering this game. Game consists of rolling a die and you get a 10 if a 6 is rolled. Anything else, you get no money. What's a fair price to play this game? So let's figure out the formula here. So this will be expected value equals the amount, which is, we don't know how much this game is to play, right? So I guess we could say like you get 10 minus A, the amount, is times the probability of winning is if a 6 is rolled, so that'd be 1/6 plus, I guess you get the negative amount. So if you you lose whatever amount you bet times 5/6. So 5/6, you're going to lose 5/6 of the time. And the thing I would change here is we actually want, in this case, we kind of know what our expected outcome is going to be. We want this to be a fair game, which means zeros are outcome. We don't want to be the odds in our favor or in the casino's favor. And so we're going to try to solve this. So this takes a little bit of work here. You might have to solve a quadratic to solve this. Well, let's just see what happens here. So we get 0 equals, let's distribute this, 10 times 1/6 is 10/6, I guess, minus A over 6 plus negative 5A over 6. Okay, so we get 0 equals 10/6. This will be like negative 1/6A plus negative, that's negative, so just minus A. So let's add A to both sides. A equals 10/6. Let's see, what is 10/6? So if you do 10 divided by 6, if you put a decimal in there, that will give you a decimal answer, $1.67. So the amount you should charge is $1.67 approximately, and that would be a fair price to play this game. And what that means is You're not gonna lose or win